Hello everyone, welcome again to this online class, and today we are going to start our another subtopic of electronics called semiconductors. But before I start semiconductors, let me thank you all for whom are giving us support by subscribing. For the one who you are new here, I would like to recommend you to subscribe, like and comment to give me a great support. So this subtopic of semiconductor is also very important, but it is also very simple. Let us now start by classifying the solid materials. So solid materials are being classified into three categories. We have the conductors as the first category of solid material, but also we have the insulators. This is another category of solid material or another class. We have the last class of solid materials. They are called the semiconductors. Let us now start by defining the conductors. So conductors, simply these are substances which are able to conduct electricity. These are materials which can allow electric current or electricity to pass through them. And the good example of conductors are metals such as copper, iron, aluminium, silver. These ones are the good examples of conductors. Let us now define the insulators. So insulators, these ones are materials or substances which they are unable to carry current or electric current. So examples of insulators, we have the wood, we have the plastic, you have the rubber, we have the sand, and these ones are examples of insulators. So insulators, they can't conduct electricity. They can't allow electric current to pass through them. Let us now see another class of solid material called the semiconductors. So speaking about the semiconductors, these ones are materials whose conductivity is between that of insulator and between that of a conductor. And the two most applicable examples of semiconductors are the germanium and silicon. So simply, semiconductors are material whose conductivity lies between conductors and insulators. So sometimes semiconductors, they act as insulators, and sometimes semiconductors, they act as conductors. Let us see the concept of electrical conductivity. So speaking about electrical conductivity is always facilitated by the electrons. Not only electrons, but the free electrons. So once the electrons becomes free, they will be able to allow electric current to pass through them. So simply, electrical conductivity is facilitated by the free electrons. So increasing the mobility of the free electron allows to increase the electrical conductivity. So simply, as I said, electrons should be free, should be mobile for them to carry electric current. So the more they become mobile or the more they become free, they increase electrical conductivity. And if mobility is limited, there will be also a limited electrical conductivity. So let us see the energy band concept. So simply the energy band, this one are large number of the secret but closely spaced the energy levels within which electrons can occupy. So these ones are energy level within which there is occupation of electron. Let us see the diagram of the energy bands. So we have the lowest band called the valence band. This one is the lowest band. So the valence band, we say this one is the lowest energy band that is completely filled with electron. We say that the valence band is full of electron. We have the highest band or the upper band called the conduction band. This one is the upper energy band that contains no electron, or sometimes it has very few electrons at room temperature depending on the material. But in between, there is a gap called the forbidden energy gap. This one is a gap between the conduction band and the valence band, but this gap is not occupied by any electron. So just a message to tell you here is that electron, in order to be able to carry electric current, they should move from the valence band and reach the conduction band. But before they reach the conduction band, they must cross a gap. This gap is called the forbidden energy gap. And if this forbidden energy gap is large, it becomes very difficult for electrons from the valence band to cross the gap to reach the conduction band. So if the gap is very small, a little amount of energy will be required to cross the gap. But if the gap is large, a high amount of energy will be required to close the gap. And if high amount of energy is required to close the gap, sometimes it is very difficult to achieve that high amount of energy. That's why an insulator is acting as a poor conductor of electricity, because this gap is very large. I will explain you in the energy band concept. Let us now see the band gap theory. So this one is a energy band diagram for conductors, for insulators, and for semiconductors. Let us see each material. How does the band gap explained? Starting by the insulators. So we say that in the insulators, the forbidden energy gap between the conduction band and the valence band is very large. The width of the forbidden energy gap is very wide. So having a much wider width of the forbidden energy gap, this tells us that the valence band electrons, they find themselves very difficult to cross the forbidden energy gap to reach the conduction band. So for electrons to move from the valence band to the conduction band, they must require a very huge amount of energy so that they can overcome this gap. That's why insulators, they act as poor conductor of electricity, simply because the forbidden energy gap is very large. So electrons from the valence band, they can't cross the forbidden energy gap to reach the conduction band. Or even if they must cross, or if they could cross, they would require a huge amount of energy. So coming to the semiconductors, they have a small forbidden energy gap. So you can see the gap is reduced. The gap in the semiconductor is reduced. The gap between the conduction band and the valence band is small. This means electrons from the valence band, they require a little amount of energy to reach the conduction band. That's why even at room temperature, you can find there is some occupation of electron to the conduction band. But even at room temperature, in the insulators, you can't find electrons. But in the conduction band, in the semiconductors, at room temperature, you can find very few electrons, because some of the electrons are able to cross the gap even at room temperature. But once you increase the temperature, you will notice that electrons will acquire some energy to cross the gap. I will explain this concept in the next class about the effect of temperature on semiconductors. So the next class of solid material is conductor, and explaining it is band gap theory. You say that there is overlapping of the conduction band and the valence band. So the conduction band and valence band have overlapped, and there is no forbidden energy gap. There is no gap between the conduction band and the valence band. So if there is no gap, this means that electrons from the valence band will easily move to the conduction band. That's why the conductors, they can easily carry electric current or electricity, because there is no forbidden energy gap. So hence, no amount of energy is required for the electrons to move from the valence band to the conduction band because the forbidden energy gap is no longer there. So let us now see the electron-hole pair. So we said that electrons do move from the valence band to reach the conduction band. Now, once electrons move from the valence band to reach the conduction band, they leave a vacance in the valence band. That vacance is called a hole and is always positive charged. So electron, once they move from the valence band to reach the conduction band, they leave a hole. And we can say that in a semiconductor, the number of holes and number of electrons are always equal because the number of electrons moving from the valence band to reach the conduction band is equal to the number of holes created or number of holes left in the valence band. So we can generally conclude that the semiconductor is neutral. Semiconductor is whole as neutral. Let us see the properties of semiconductor. The first property of semiconductor, we say it has a negative temperature coefficient of resistance. So speaking about negative temperature coefficient of resistance, this means once temperature increases, resistance decreases. And once temperature decreases, resistance increases. It is like the vice versa. Increasing temperature decreases resistance. Decreasing temperature increases resistance. And this one is the actual meaning of negative temperature coefficient of resistance. Just to remind you, this question is very common. Maswali ya design hii utayakuta sana kwenye mtihani wako. Yaani huwezi kuyakwepa. Kwenye moko, kwenye NECTA, mtihani ya ndani, ni maswali ambayo ni yako common sana kukutana nayo. Utaambiwa mention maybe 4 characteristics of semiconductor, you'll be awarded 0.5 marks in each point you mention or 1 mark in each point you mention. Ni maswali ambayo ni ya bure, maswali manahisi, utakiwi kukosa. Unapozidi kuendelea kusoma hii subtopic, nikukumbushe tu kama kuja subscribe, tafadhali subscribe. Tatumia a lot of MBs, tatumia a lot of time. Support yako kubwa ambayo unaweza kaitoa ni kusubscribe, ku-like na ku-comment. Okay. So another properties of semiconductor, we say they do not obey Ohm's law. Semiconductor don't obey Ohm's law. But another property of semiconductor, we say that they are formed by a covalent bond. And another property of semiconductor, we say that their conductivity can be changed by doping. In the next class, nitaelezea masuala ya doping, nitaelezea method of doping, nitaelezea types of doping and how doping can affect the electrical conductivity in semiconductors. So another properties of semiconductor, you say that their conductivity lies between that of insulator and that of a conductor. I think this one I already explained in the definition of semiconductor. Coming to the last property of semiconductor, but not least, we say that semiconductor, some of them are sensitive to light. So these ones are the properties of semiconductors. Nimekupa properties 6, lakini I'm sure zipo zaidi ya hizi. So you can go and read some other books and you can have a lot of points. But to start with, points 10 nyingi, maana kwa mtihani unaweza kambu mention 5, mention 4, 3, 2. I think it will be easy for you to answer your questions. So up to this point, this one is the end of the semiconductor part 1. Nikukaribishe sasa kwenye semiconductor part 2 in the next class. Enda fuatilia vipindi hivi kama ni wanafunzi wa A-level. I hope vitakuwa msaada mkubwa sana kwako kwa ajili ya kujibu mitihani, kufaulu mitihani, na unapomaliza form 6 kwenda kusoma course ya ndoto yako.